if each and every element of X has an unique association with the elements of the set Y, then f from X to Y is called a function. Every element of codomain set have a pre-image, then such function is called an onto function. One element of the domain set is connected with one element of the codomain set, then it is called a one-one function, or it is also called as an injective function. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the relations. Now, in this session, I am going to discuss regarding relations as well as the functions. Now, here, let me know regarding the functions. In this second concept, I am going to discuss regarding the functions and the types of functions and the problems based on those functions. Now, in my previous class, we have discussed regarding a function and problems connecting to the function. Let me recall the definition of a function. So, what is a function? So, a function, now let us consider two sets. Let X and Y are any two non-empty sets. So, if X contains the elements A, B, C and Y contains the elements 1, 2 and 3, if there is a unique association from A to B, that is from X to Y, if there is an unique association from the set of elements X to set of elements Y, then this is called a function, denoted as f from X to Y is a function. Now, how to define a function? For any two non-empty sets, if let X and Y are any two non-empty sets, a function f from X to Y is defined if every element of set X has a unique mapping, unique association with the element of set Y. Then this is denoted as f from X to Y is called a function. Okay, this is an example for a function. Here, the element A, B, C of X is an unique association with the elements of set Y. Now, and we have already studied regarding the domain and range. The first elements, all the first elements is called the domain, right? So, here the set X is called the domain of the function. Therefore, X is equal to A, B, C is called the domain. This is called the domain of the function, and the set X is equal to A, B, C is called the domain of the function, right? The set Y is called the codomain. The set Y is equal to, what is Y contains? 1, 2 and 3. This is called the codomain of the function f. So, codomain, the set X is called the domain and Y is called the codomain of the function. And the images are called the range, that's it. So, the images, all the images, that is called the range. So, the range of the function is given by range is equal to 1, 2, 3 is the range of the function. That's it. Domain, codomain and the range. That is, we have discussed this already in the previous classes. Let us come to the different types of function. The first one is one-one function, or it is also called as a injective function. One-one function, or it is also called as an injective function. A function f from A to B is said to be one-one function if one element of the domain set is connected with one element of the codomain set. Now, let us consider two sets. Yes, here f1 and f2 are two sets. Let us consider the function f1 and f2 are two functions. Check whether it is one-one function or not. So, let us consider A, B, C, D, A 1, 2, 3, 4, 5, 6. The elements of, let us consider this as elements A and B. Now, A to 4, B to 5, C to 2 and D to 6. This is the mapping. So, therefore, f1, this all the elements of A has a unique association. So, that is A to 4, B to 5, C to D, C to 2 and D to 6. That is, one element of the domain is connected to one element of the codomain set. Therefore, this is one-one function. Similarly, let us come to this function f2. Let us represent this as A and B. A contains A, B, C, D, B contains 1, 2, 3, A to 1, B to 2 and C to 3. Here also one element of the set domain set is connected with one element of the codomain set. Therefore, this is also an example for a one-one function. So, in general, How to define one function? A function f from x to y, a function f from x to y is said to be one function if distinct elements of x will have distinct images in set y. Distinct elements of the set will have the distinct images in the set y, then it is called one function. So, suppose if for all x1 comma x2 belongs to the set x, if f of x1 is equal to f of x2 implies x1 is equal to x2, then f of x is said to be a one function. This is very important definition. So, that is for all x1, x2 belongs to the set x, if f of x1 is equal to f of x2 implies x1 is equal to x2, then f of x is said to be an one function. Okay. That is, if distinct elements of x will have the distinct images in y, then f from x to y is said to be one function. That is, f of x1 is equal to f of x2 implies x1 is equal to x2, then f of x is a one function. This is an example for one function. Now, let us come to the second type, surjective function, or it is also called as an onto function. Onto or surjective. A function in which every element of the codomain set has one pre-image. Every element of the codomain set, every element of codomain set have a pre-image, then such function is called an onto function. Onto function. Let us consider, for example, if a is equal to 1, 2, 3, 4, b is equal to a, b, c, d, and the function, this is given by here a, this is a and b. A contains, what are the elements of a? A contains 1, 2, 3, 4 and b contains a, b, c, and define the function. So, the mapping is 1 to b, 1 to b, again 2 to a, 3 to c, and again 4 to c. So, it is surjective function as every element of b is the image of some elements of a. Every element of this b is some image of some elements of a. That means, all the elements of b have the images under a. So, therefore, f from a to b, f from a to b is called an onto function. This is called an onto function. That means, a function in which every element of the codomain set has one pre-image. That means, here the function as every elements of b is the image of some element of a. Every element of b is an image for some elements of a. So, therefore, f from a to b is an onto function. That is how to define a function f from x to y. A function f from x to y is called onto function if every element of y has a pre-image of x. Every element of y is an pre-image of x, then such function is called an onto function. Now, let us come to the next one. So, bijective function. Bijective function means one and onto function. A function which is both one and onto. See, a function which is both injective, one to one, and surjective, onto is called a bijective function. A function which is both one and onto is called a bijective function. Very important. A function which is both one and onto is called as a bijective function. Now, let us consider, for example, if p is equal to x, y, z, and another set q is equal to a, b, c, then f from p to q such that the function f is given defined by x comma a, y comma b, z comma c. Now, let us write down here p contains x, y, z, and q contains a, b, c. What is the mapping given? F of x comma a, x to a, y to b, y to b, and z to c. This is c, z to c. Let us consider this function. In this function, so here f is given by f is equal to x comma a, then y comma b, and z comma x. This is a one and onto function. If we consider this example, let us consider the elements here. This is p and q. So, what is p contains? P contains x, y, and z. Q contains a, b, c. The mapping x to a, then y to b, and z to c. This is f from p to q. F from p to q is both 1 1 and onto function, hence it is a bijective function. Bijective function. That's it. So this is both 1 1 as well as onto a function which is both 1 1 and onto is called as a bijective function. So this is an example for a bijective function. Now let us come to the next type of function, into functions. Into function. What is an into function? Means if any one of the element of the set B does not have image in the set A, then it is called an into function. How to define a function in which there must be an element of codomain Y does not have any pre-image in the domain X. If at least one of the element in the codomain is not used, then it is called an into function. That is how to define a function in which there must be an element of codomain Y does not have any pre-image in the domain X, then it is called an into function. Let us consider, for example, if A contains A, B, C and B contains 1, 2, 3, 4, let us map. What is the map given? A contains A, B, C and B contains 1, 2, 3. F from A to B is defined by F is equal to A to 1, B to 2 and C to 3. A to 1, that is map A to 1, B to 2 and C to 3. Just watch carefully here, the element 4 does not have any pre-image. The element 4 is not used. The element 4 of the set B is not used. That means the element 4 has no pre-image. Therefore, this is an example for an into function. We can write F from A to B is an into function. Into function. That means, see, A, that is 1, 2, 3 is not equal to codomain. That is Y. What is codomain? 1, 2, 3, 4. Therefore, it is an into function. Here, the elements 1, 2, 3 is not equal to codomain of Y. What is codomain of Y? 1, 2, 3, 4. Therefore, this is an example for into function. In general, at least one of the element in B should not have any pre-image in set A. Then it is called an into function. That's it. Now, let us come to the next one. Many one functions. Many one functions means let F from X to Y be a function. The function F is said to be many one functions if there exist two or more than two different elements in X having the same image in Y. If there exists an element which will have more than two different images in Y. So, there exists two or more than two different elements in X having the same image in Y. Such a function is called many one functions. Now, let us consider, for example, let A is equal to 1, 2, 3, 4, 5 and Y is equal to X, Y, Z. Define a function F from X to Y as 1, X, 2, X, 3, X, 4, Y and 5, Z. Then, let us map 1, 2, 3, 4, 5 are the elements of set X. X, Y, Z are the elements of the set Y. Map, what is given? 1 to X, 1 to X, again 1 to X, 2 to Y, again 3 to X, again 4 to Y and 3 to 5 to Z. So, 1, X, 2, X, 3, X, again 4, Y and 5, Z. Here, F of function is nothing but this function is called a many one function because the element X have different images. So, 1, 2, 3 are the images. So, therefore, this is an example for a many one function. The element 1, 2 and 3 is associated with a single element X. That means, if there exists two or more than two different elements in X, two or more than two different, here three elements of X is associated with the one element in Y, that is X. So, therefore, this is an example for a many one function, that is more than two elements or one or more. If there exists two or more than two, if there exists two or more than two different elements in set X have the same image in Y, then it is called a. So, here the elements 1, 2 and 3 is associated with X of second set, that is Y. Therefore, this is an example for many one functions. Now, let us come to the next type of function, many one onto function. Many one onto function. So, a function which is called many one onto function is called many one onto function if and only if it is both many one and onto function. A function which is both many one and onto is called many one onto function. Now let us consider an example. If a is equal to 1, 2, 3, 4 and y is equal to k and I, and check whether the function f from x to y is many one and onto function. Now let us define the function f is equal to 1 comma k, 2 comma k, 3 comma I and 4 comma I. See here, the element k have two images. Here also the element I have two images. That means the function f is many one as two elements have the same image in y, as two elements of x will have the same images, as two elements have the same images in y, and it is onto, as every element of y is the image of some element in x. So every element of y is an image of some element of x, that is an onto. Therefore, this is an example for many one function and onto function, that is many one onto function. See here, the function f is many one as, what is the reason? As two elements have the same images, two elements of y have the same images. So element k have image 1 and 2. Similarly, the element 1 has two images 3 and 4. Further, every element of y is the image of, every element of y is the image of some element of x. So it is onto. Therefore, the function is many one and onto function. This is an example for many one and onto function. That means a function which is both many one as well as onto is called many one onto function. Now let us come to the next, identity function. So identity function, a function f is called an identity function if each element of set A has the image on itself. So each element of the set A has the image on itself is called an identity function, denoted as f of A is equal to A for all A belongs to A, and it is denoted as I. I is an identity function. Now let us consider an example. If A is equal to 1, 2, 3, 4, 5 and a function f from A to B is defined by 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 and 5 comma 5, then the function f is an identity function as every element of A is mapped onto itself. Thus the function is 1 1 and onto function, 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5. So 1 1, 2 2, 3 3, 4. So that means the each and every element of the set A has an image of itself, 1 to 1, 2 to 2, 3 to 3, 4 to 4. So image of 1 is 1, image of 2 is 2, image of 3 is 3, image of 4 is 4, image of 5 is also 5. Therefore, this is an example for an identity function denoted as I or IA. This is f is 1 1 and onto function. Now let us come to the next one, invertible, that is inverse function. This is very important concept, invertible function and inverse function. So a function f from x to y is invertible if and only if it is a bijective function. A function which is both 1 1 and onto is called an invertible function. The function is said to be invertible if and only if it is a bijective function. Bijective function means if it is both 1 1 and onto function. So a function which is both 1 1 and onto is called a invertible function. Now consider the bijective function 1 1 and onto function f from x to y, as f is 1 to 1 and therefore each element of x corresponds to a distinct element of y. As f is onto, there is no element of y which is not the image of any element of x. Therefore, the range is equal to codomain. The range is equal to codomain. So therefore, the inverse of f exists and it is denoted as f inverse. This is called the representation of an inverse. F inverse is a function from y to y. Yes, if f is a function from x to y, then if it is both 1 1 and onto bijective function, inverse exists and f inverse is given by f inverse is equal to y to x. This is called an invertible function. F from x to y is a function. If it is both 1 1 and onto, then the inverse exists and that invertible function is given by f inverse is from y to x. So the inverse of the function f is denoted as f inverse is a function from y to x. That's it. So that is regarding invertible functions. Hope you followed. Now let us take an example based on this. Now consider x is equal to 1, 2 and 3. Let us consider a set x is equal to 1, 2, 3 and y is equal to k, l, m, and define a function f from x to y such that f is equal to 1 comma k, 2 comma m and 3 comma I. K, L, M. So k 1 to k, 2 to m, 3 to l. So listen, let us represent this in a diagram. X and y, the elements of x are 1, 2, 3 and y, k, l, m are the elements of the set y. Now here f from x to y is a function. F from x to y is a function. And now let us come to this function. X and y, what is x contains k, l, m and y contains 1, 2, 3 as usual. Now the mapping, yes, mapping x k to 1, l to 3 and m to 2, this is called the inverse of the function. So f inverse is a function from x to y. F inverse, this is the inverse function. See, that is k to 1, l to 3 and m to 2 is called the invertible function. This is the inverse of the function f from x to y. That's it. Okay. So hope you followed. So in general, a function which is both 1, 1 and on 2 is called an invertible function, denoted as if f from x to y is 1, 1 and on 2, that is a bijective function. If it is bijective function, both 1, 1 and onto function, then this is called an invertible function, which is denoted as f inverse is a function from y to x. This is an invertible function. That is, this is an example for a invertible function. F from x to y is a function and f inverse is a function from x to y. That is k to 1, k, l to 3 and m to 2. This is called an invertible function. Hope you followed. So these are regarding the definition of a function as well as different types of the functions. Okay, these are all the basics of relations and functions in discrete mathematics. So that's all regarding today's session. Let us meet with the different concept in the next session. Thank you very much.